Hello guys, welcome to my YouTube channel. So in this video, we are going to see how we can assign R and S configuration to various chiral centers in the molecules we have above. Now, the basis on which we assign R or S configuration to a chiral center is based on Cantrell rules that give us the guidelines on how to assign R or S configuration to various chiral centers. Now let's start with the simpler ones. We have this one. We have the chiral center, that's the carbon attached to various substituents. We have bromine, we have iodine, we have methyl, then we have hydrogen. So this sign here shows that it's located to the back. Then this one to the front, of course, now to interpret those ones. So we are going to assign ROS configuration based on high priority groups. And how do we know that which group is of high priority? Based on the atomic number. So, in the periodic table, when you compare between iodine, bromine, hydrogen, and the methyl group, you realize that iodine has the highest atomic number. And for that reason, we are going to assign it the highest priority. So, we are going to get there 1, then followed by bromine, 2, then 3. Hydrogen is always the least, 4. But remember, before you assign ROS configuration, you must make sure that the fourth one is located at the back. And this is what shows you that it's located in the back. Now, number 4 is hydrogen, located at the back, to mean we are good to go. Now, let's go ahead and assign the ROS configuration. And another thing, you can cross number 4 because you won't need it. Then trace the arc on from 1, 2, and 3. So we have 1, 2, 3. So the arc is going this way. So when it is clockwise, it is R configuration. When it is counterclockwise or anti-clockwise, we assign S configuration. So the configuration is going this way. That is R configuration because it is clockwise. Now, let's get to this one. We have the chiral center there. We have the groups iodine, bromine, methyl, hydrogen, just the same groups. But let us see what's going to happen this side. We say the priority is based on atomic number. So hydrogen take the lead, number 1, then bromine, number 2, then methyl group, number 3, then hydrogen, number 4. Remember, before you assign the ROS configuration, number 4 must be to the back. This is what shows us that is located in the back. So we are good to go. We can now go ahead and assign the ROS configuration. So you can cross it because you want to need it while tracing the arc. So now draw the arc from 1, 2, 3 so as to get which configuration we assign to that particular chiral center. So you have number 1, number 2, number 3. So draw an arc. So this is counterclockwise or anti-clockwise, and therefore we assign S configuration. This is our configuration. Now let us go ahead and get to solve. At least this one is slightly complicated. Now we have this chiral center here. It's attached to. You have this group. Now we have the ethyl group. We have bromine, methyl, and others. So now let's see on which basis do we assign the priority based on atomic number on the molecule or the atom that is attached to the directly attached to the chiral center. So let us see. We have bromine, we have carbon, then we have carbon. So between bromine and carbon, bromine takes the lead, of course. So we are going to assign 1 because that's a high atomic number on the periodic table as compared to carbon. So now that these carbons have the same atomic number, we have to go ahead. So on this carbon, we have another carbon attached to it. On this, we have a hydrogen attached to it. Then on this, we have an oxygen attached to it. So we are comparing oxygen, hydrogen, and carbon. So of course, oxygen takes the lead. Is that high atomic numbers compared to carbon and hydrogen? Then number 3 will be that. Then methyl group takes the least. Now, just as I said, the last group, number 4, should be facing the back. So you are good to go because it's facing the back. Then you can now close it. So We can now trace our arc. We have 1, 2, 3. So the arc is going this way. Now, which configuration is that? That is the counter-clockwise direction. So we assign S configuration. Now, feel free to pause the video and attend this one. So we have this molecule here that has more than one chiral centers. So we're going to see how we can solve that one. Now remember, this is called Fischer projection. Fischer projection, and these junctions we have carbon atoms. Now let us see. On this carbon atom, we have bromine attached to that. We have methyl. We have hydrogen. And we have all these other groups. Now, let us see which groups are directly bonded. So, of course, here you have hydrogen, here we have carbon, and this carbon. So, we are using this, we are on this first carbon. So, 1, 2, 3, 4, 5. So, on this first carbon, we have bromine, we have carbon, we have hydrogen, and another carbon. So, bromine takes the lead. Then, we have a carbon, then hydrogen. So on this carbon we have a hydrogen attached, bonded to it. Then on this carbon we have hydrogen, because we have chlorine and all this other group. So this one will take the lead. Now, then number 3 will be the methyl group. Then hydrogen always least. Now, these vertical lines show that they are oriented facing back, they are facing away. Then these horizontal lines means that they are facing you, facing this side. So we said that the last group must face away. So to mean this hydrogen should be on the vertical lines. Now let us try to trace our arc. Now we have 1, 2, 3. So it is going this way. However, our fourth group is not located on the back. So what are we going to do? We are going to reverse the configuration such that this is counterclockwise, meaning it is S configuration, but you are going to reverse it because our fourth group is not located on the behind. So it is going to be R configuration. So this is on carbon 2, we have R. So let us now go to carbon 3. So on carbon 3, we have a chloride group attached to it, we have ethyl group, we have hydrogen and all these other groups. But let us now see the atoms that are directly bonded to the chiral center. So here we have carbon, hydrogen, chloride, chlorine, and this carbon here. Now, between chlorine, carbon, hydrogen, and carbon, chlorine takes the lead. We're going to assign it the highest priority. Then we have carbon and carbon. This one is always the least. Hydrogen is always the least. Now, carbon, they are the same. But let us see other groups that are bonded to them. So this carbon is bonded to a methyl group, a bromide group, and a hydrogen group. Now, but this one is bonded to another carbon, while this one is bonded to a bromine. So what are we going to do? We're going to assign this carbon the second priority, then the third priority, then hydrogen is always the fourth. So just as we did here, number 4 should be facing the back. Now let us trace our arc. It is 1, 2, 3. So we go this way. To mean it is clockwise, it's going in a clockwise direction. That is our configuration. However, our number 4 is not located on the back, so we are going to reverse the configuration. So that it was R, then now it is S, and that is on carbon number 3. So you have to locate that kind of center to which we are assigning the configuration. So that is 3S. So the overall configuration that will be 2R, 3S. Now, that is when dealing with Fischer projection, most likely or most probably when they have 2 or more chiral centers. Now, let us get to this other one. Feel free to pause the video and attempt it in your home to ensure that you really understood this concept of R and S configuration. Now, we have a carbon here, then we have a carbon here. Now, we are going to use the same formula. We have carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Now, carbon number 1, we have carbon attached to it, we have hydrogen, you have oxygen, and you have this other carbon. So let us assign priority. So between carbon, oxygen, and the carbon, oxygen typically we're going to assign number 1. Then carbon, we're going to go ahead and confirm the groups that are attached to them. Now, this one we have a bromine group, then this one we have a carbon. So of course these are just the lead. That means number 2, then number 3, then hydrogen is always number 4. And just as I told you, in fission position, these horizontal lines mean that they are oriented towards you. And our number 4 is facing us, of which it should not be so. It should be facing away. So to mean you are going to get the configuration, then you are going to reverse the configuration. Now, we have our number 1 here, 2, 3, so let us test that up. It's going to be this way. To me, it is clockwise. That is our configuration. However, we are going to reverse it because our number 4 is facing us and it should be facing away. So we're going to reverse the configuration so that it was our configuration as now going to be S configuration. And it is on carbon number 2. So 2S. So there is also assigned the configuration at carbon number 3. Carbon number 3 is directly connected to this carbon, hydrogen, bromine, and another carbon. So let us see. Carbon, hydrogen, bromine, and another carbon. Of course, bromine takes the lead. That's number 1. So we have a carbon and a carbon. This one is attached to hydrogen group. This is attached to hydrogen, methyl, oxygen. You see. So I will assign this one higher priority adjustments to the methyl group. So then number 3 is going to be. Then number 4. Finally, is hydrogen. It is facing us. We are going to reverse the configuration as a matter of fact. Now, we have 1, 2, 3. So we are going to go this way. That is S configuration. But remember, it is facing us and it should be facing away. So we are going to reverse the configuration. That is, and this one carbon number 3. So 3. So the overall configuration will be 2 S 3 So you must specify which type of center do you assign which configuration. Thank you very much and make sure you subscribe to my YouTube channel for more amazing videos. Thank you.